So initial value problem and boundary value problem. To find the solution, so today we are going to talk about the initial and boundary conditions. And for initial condition and boundary condition, let me discuss if you are solving a second order differential equation which is linear, homogeneous or non-homogeneous. So as for the second order, I have written, for the second order we are getting two constants, and the value of the constant can be determined either by applying the initial condition or the boundary conditions. So with the help of an example, we see how to determine these constants A and B. So let me discuss initial condition. So here the function means the unknown function. So this is the differential equation I have written, which is homogeneous and linear with constant coefficients. So the solution of this differential equation will consist of two constants. The two constants can be determined by applying two conditions. Let me have this equation, and the condition I am having x naught is suppose A and y prime x naught is suppose B. So these are two conditions. This is the unknown function I am talking about. This is the function which is unknown y, and this is the independent variable. Similarly, this is y prime, and here this is the independent variable. So in these two equations, my independent variable is x naught. Independent variable is x naught. So the function value is A when the independent variable x naught, and the derivative is B when the independent variable is x naught. So it means if we are talking about higher order, so more constants are there and more conditions are there. Which we are going to BVP, boundary value. So let me have the same equation again, a2 y double dash plus a1 y dash plus a naught y equal to 0. Here the condition might be x naught is A and y of x1 is B. So these are the conditions in which the independent variables are different. And this same function is evaluated at two different points. So at two different points of the independent variable. If this is the situation, then the problems are called boundary value problem. Let me have an example. Solve the following initial value problem. Let me have y double dash minus y0. y0 is 0 and y prime 0 is 1. So this is a second order linear homogeneous differential equation. So let me write down the solution for this in D operator form. In D operator form, that is, capital D is d by dx, a differential operator. Equation 1 can be written. this is d square minus 1 operate on y equal to 0. Because d by dx is capital D, so here the double derivative shows d2 by dx2, which is going to be d square. So this is the equation. Now from this we are writing auxiliary equation. Auxiliary equation is r square minus 1 equal to 0. So this is a quadratic equation and the roots are plus minus 1. The roots are plus minus 1, so solution of equation 1 can be written. Solution of equation 1 can be written. Y is equal to AEX plus BE minus X. The solution, because these are root plus minus 1, and here we have this is plus 1 and this minus 1. You can write either here E minus X, here E plus X, because addition is commutative, you can write. So this is the solution of a differential equation. Since we are talking about second order, there are two constants there. And these two constants can be determined by these two conditions. One is on the function, one is on the derivative. Let me call it equation 2. Differentiate equation 2. With respect to x. So this is y dash is equal to AEX plus BE minus X, and the derivative of minus X is minus 1 there. So it is going to be simplified a little bit more. Minus BE minus X, this is y prime. So call it 3. So this is equation number 2 and this is 3. A and B are two constants. Let me apply the condition one by one. Y0 is 0. It means this is my x and this is y. Similarly, this is independent variable x and this is y prime. So put x is equal to 0, y equal to 0 in equation 2. So I will have this is 0 is equal to A E0 plus B E0. So this become 0 is equal to A plus B. Another time I am put x is equal to 0, y prime is equal to 1 in equation 3. So y prime is 1. This is 1 is equal to A minus B. So here is A plus B equal to 0 and here A minus B is 1. So two equation, two unknown. Solve them simultaneously the way you solving and finding A and B. If I am adding, so I'll get adding. So these two equations, so 2A is equal to 1, this implies A is equal to half. If A is equal to half, so 0 is equal to half plus B. This implies B is equal to minus half. So we are solving these two simultaneously. If we are adding A plus A, 2A is equal to 1, B and minus B cancelled. So 2A is equal to 1, it means A is equal to half. So A is equal to half, putting there, you are getting B is equal to minus half. Since you have A and B, putting back in the solution, equation 3. The required solution is therefore y is equal to A is half. Here I am putting A. A is half EX as it is. B is minus half. Minus half E minus X. So this is all about the initial value problem which we have solved. by using these two conditions, which are initial condition, function and its derivative at a particular point. This point must be the same. It could be any real number, 0, 1, 2, 10, whatever it is. So you can have. So if I am not writing this, suppose these are not, the initial conditions are not written, then this will be the solution. This is the solution required. But since the conditions are given, so it means you have to find the value of A and B. So putting the value of A and B back to the solution, you are getting the required solution. So let's have another example. Solve the following initial value problem. So y double dash minus 4y is 12x, y0 is 4 and y prime 0 is 1. So this is non-homogeneous equation. Non-homogeneous because of this function present. If I am not writing this function, for example, let me write 0 there. So this is homogeneous. We have just finished to solve a homogeneous differential equation. But let me have another which is non-homogeneous. Because two terms, one is the derivative, one is the dependent variable, but here this is an unknown function, which you do not know which function is this. So this is a second order linear non-homogeneous differential equation. Let me call it 1. Solution of equation 1. Solution of equation 1 will consist of two parts. Since it is non-homogeneous, we are having two parts for the solution. One is the complementary function. Is obtained by the homogeneous differential equation. Homogeneous differential, which is y double dash minus 4y equal to 0. So this is homogeneous. According to the definition, each term is either the derivative or the dependent. There must not be anything for it. So again, D operator form. Homogeneous differential equation can be solved by the method D operator. So for D operator form, I am writing D square minus 4 operate on y equal to 0 because operator is operated on some unknown function y. So I am writing auxiliary equation from this step, which is r square minus 4 equal to 0. And this is quadratic, the roots are plus minus 2. So if the roots are real distinct, solution of the homogeneous differential equation. Solution of homogeneous differential equation is written by C, because I have written here the complementary function. Complementary function, let me name it as yc. So the roots are real distinct. Again, I am writing the solution a e 2x plus b e minus 2x. This one part is finished. Now I am going to find, since this is non-homogeneous because of this function, so the other solution is by p, the particular integral. Its name is the particular integral. Can be calculated. By p is equal to 1 over polynomial in d into f of x. So this is one of the method to find this function is your f of x. It could be anything. It is sine, cosine, the exponential, the constant, whatever it is. So this time it is a polynomial f of d. The polynomial in d is this. This is the polynomial. Polynomial in d I am writing there. D square minus 4 and f of x is 12x this time. And we have discussed previously, when this function is a polynomial, we have to expand this using binomial series and operate on this. For finding the binomial, we are familiar one term must be 1. If it is going to be 1, naturally that's okay, but it is not 1. What I am going to do is I am taking minus 4 outside. This is 1 minus d square by 4, 12x. So I have to have one term 1. If it is naturally 1, that's okay, but it is going to be minus 4. The lowest degree of the polynomial should be taken out. Not you are going to take d square out. So you said, I will take d square. No. The lowest degree term should be taken out to make it 1, and then you can do this. Let me write this. So y is equal to minus 1 by 4. This can be written 1 minus d square by 4 raised to the power minus 112x. Now I am expanding this using binomial series. So this is minus 1 by 4 there, 1 plus d square by 4 and 12x. I have to stop because d square mean d2 by dx2. This is what I mean is by d square, and this d square is operated on this function. Since this is a polynomial of degree 1, after differentiating once, it will give you constant 12. So no need to be d square. So it means this d square is not working on it. So let me have a minus 4, let me consider 3. Let me have 4. Minus 3 is taken out, and this is 1 plus d square by 4 operate on x. So this become minus 3 there. This is operated on x. 1 is multiplied with x, and then d square mean twice differentiate. Differentiate twice, which is going to be 0. So this is minus 3x is your yp. You have yc here, this is your yc, and then this is the yp. Now, the general solution. The general solution of equation 1. Equation 1 is the non-homogeneous equation. We have two solutions separately, and now I am writing the general solution. Y is equal to yc plus yp, adding them together. So this is ae 2x plus be minus 2x and minus 3x. This is your y. This is the general solution. And if I am not writing the conditions, that will be the solution. But since the conditions are there, it means you have to find the value of a and b. So here this is your x and this is your y. And this is your x and this is your y prime. So let me differentiate with respect to x. Differentiate with respect to x. This is y prime is equal to 2a e2x. Because if you are differentiating this is e2x and the derivative of this, which is 2 here. Then minus 2b e minus 2x and minus 3. Call it 2 and call it 3. So equation 2 and 3 can be used to find the value of a and b. Put x is equal to 0, y equal to 4 in equation 2, and x is equal to 0, y prime is 1 in equation 3. So we can have this. Y prime is 4. So 4 is equal to, here I am putting 4 is equal to x is 0, a plus b minus 3 times 0 is 0. Again, y prime is, this is single derivative. Y prime is 1. 1 is equal to 2a minus 2b minus 3. So these two equations, two unknown. From this equation, I'll have a is equal to 4 minus b. Put in, let me have fourth. This a is equal to 4 minus b from here. Put in equation 4. 4 मिल गया. 1 is equal to 2. A is written 4 minus b minus 2b minus 3. Let me solve. 4 to the 8 minus 2b minus 2b minus 3 is equal to 1. So minus 2b minus 2b minus 4b, 8 minus 3 is plus 5 is equal to 1. So it means minus 4b is equal to 1 minus 5, which is minus 4 minus 4b dividing by minus 4. This goes. This implies b is equal to 1. If b is equal to 1, put it here. A is equal to 3. B is equal to 1. A is equal to 4 minus b, which is 3. So you have b is 1, a is 3 right down there, which is the equation to the general solution we are having. The required solution is therefore is y is equal to a is 3. 3 e 2x and b is 1. E minus 2x and minus 3x. So this is the general solution after you have determined the value of a and b. Follow-ups. Solve the following initial value problem.